This video will discuss the solution to question 28. What is the output resistance of the amplifier in figure 2? That is to say, what is the equivalent resistance at node Vout? So in this question, we're asked to compute the equivalent resistance at node Vout. To do that, we first have to make a small signal equivalent of this part of the circuit. So let's make that. You may now be tempted to say that the output resistance at Vout is just this RO, because indeed it is a resistance. However, that's not the full story. If we want to measure the full output resistance, we have to take a voltage source at the specific node where we want to measure the output resistance and inject a voltage in there, so a test voltage, let's say Vx, like this. And then we measure how much current will enter the circuit, Ix. To then get the full output resistance, we can just divide Vx by Ix. We also have to look at what the source and gate voltage of this PMOS transistor are. The source voltage in this case is the same voltage as the output voltage, so in our small signal drawing there will be Vx. And the gate voltage is going to be ground. The reason for this is that we are measuring the output resistance of this node, and therefore all other current and voltage sources are disconnected. So this signal source is currently shorted. There is a ground at this node, and therefore there's no amplification effect from this node to that node. In other words, the gate node of the second stage, right over here, will see a constant voltage, which in a small signal analysis is a ground. We can now use nodal analysis to express Ix in terms of the two currents that pass into the two branches. So we can rewrite this equation to get Rout, which is equal to 1 over Gm plus 1 over Ro. The two quantities, Gm and Ro, can be computed with the parameters given in the figure. The transconductance gain, Gm, is equal to 2 times the large signal current over the overdrive voltage. That's equal to 0.2 milliamps over 0.2 volts. And that gives us 1 millisiemens. The resistance Ro is given by the early voltage, Va, over the channel current, Id. Both parameters are given in the figure here, so that is 10 volts over 0.1 milliamps. And that gives us 100 kilo ohms. If we now fill in both parameters into the equation above, we will get that the output resistance in the node Vout is 1 kilo ohm.